Hello, hi everyone. Today we are going to discuss a topic named minimum number of teeth on pinion to avoid interference with rack. So to avoid interference, the one of the method is to maintain minimum number of teeth on gear. Here we are going to discuss how many number of teeth on pinion should be maintained so that there will not be interference with the rack. Now what is rack here? See here, this is rack and it is engaged with the pinion. So it is a rack and pinion arrangement. Here rack is the part of a gear wheel having infinite diameter. So as the diameter is more, its base circle diameter and profiles of involved teeth are straight lines, and these straight lines are tangential to tooth profiles of this pinion profiles. Correct? So that's why it is tangential to this pinion profiles. Now we have to find value of, here point F is the interference point. We have to find the value of addendum of rack. So what is the value of addendum of rack? Just look here, point B. Now it is the center point of pinion. Small r is nothing but pitch circle radius of the pinion, PCR of the pinion, and we know the value of pitch circle radius is m into Zp divided by 2. So what is Zp here? Zp are the number of teeth on pinion. M stands for module. It stands for module, which is expressed in terms of mm. Phi is the pressure angle, and a suffix r is the addendum of the rack. So addendum of rack is equal to fraction by which the standard addendum of one module is multiplied. So it is AR multiplied by module. This is the M stands for module. So AR is the fraction by which the standard module is multiplied by. Okay, is it clear? Now see here, as it is a pinion, we are considering pitch circle of the pinion like this. As we have already discussed, the pitch line of the rack, it is straight line as it has infinite diameter. Now we have drawn here, point P is the point of contact over here. We have drawn line EF like this by this red color line. Now we have to find addendum of this rack. So addendum of rack will be this one. So distance B to distance point B to point H, it is nothing but addendum of the rack. So we will find value of addendum of rack. So addendum of rack is nothing but distance BH. So now observe this, phi is the pressure angle. Here this is the phi, value phi, it is 90 degree. So we can write value of BH in terms of trigonometry. So as this angle is phi, BH is the opposite side. So we can write BH is equal to this hypotenuse PB multiplied by sine of phi. So BH is equal to PB multiplied by sine of phi. So addendum of rack can be written in terms of this AR into M. So small AR multiplied by M. Now we have to find value of this PB. So PB, now consider triangle OPB. So from this triangle, it is a phi angle. So we have to write value of this PB. PB is the opposite to angle. So it's a sine value. So we can write this AR into M as it is. PB can be written as, this is right angle triangle. So PB is equal to OP into sine of phi. So PB is here OP into sine of phi. Outside the bracket sine phi as it is. So what is value of OP? OP is nothing but pitch circle radius of pinion. So we can write OP is here R into sine phi sine square of phi. So it is AR into M. What is value of R? We have already written. R is M into Zp by 2. So AR multiplied by M is equal to, replace R with M Zp by 2 into sine square phi. So see here, we can cancel. So here value of ZP we have to write from this equation. So modifying this equation, we can write value of ZP, minimum number of teeth on pinion, is equal to 2 into AR divided by sine square phi. Correct? ZP is equal to 2 into AR into sine square of phi. So ZP is the minimum number of teeth on pinion to avoid the interference between pinion and rack. So this equation is used to calculate value of minimum number of teeth on pinion to avoid the interference with rack. Okay, so I think you got this concept. Thank you all of you.